Hey everyone, Sefki here, and welcome to my channel where we explore the most mind-blowing corners of the universe. Today, we're diving into a topic that sounds like it's straight out of science fiction quantum entanglement. Now I know what you're thinking, quantum physics? That stuff makes my brain hurt. Trust me, I get it. But the truth is, quantum entanglement is one of the most fascinating and potentially revolutionary discoveries in all of science. It could change everything from how we communicate to how we explore the cosmos. So buckle up. Get ready to have your mind blown, because we're about to embark on a wild ride through the weird and wonderful world of quantum entanglement. So what exactly is quantum entanglement? It's a question that has puzzled and fascinated scientists for decades. In a nutshell, it's a strange phenomenon where two particles become linked, no matter how far apart they are. This connection is so profound that the state of one particle instantly influences the state of the other. Imagine you have two coins, and you flip them both. Normally you'd expect each coin to land independently of the other. You wouldn't be surprised if one landed on heads and the other on tails, right? Each coin flip is a separate event with its own outcome. But, in the quantum world, things get weird. The rules that govern particles at this level are completely different from our everyday experiences. If these coins were entangled particles, they'd always be correlated, even if they were light years away. This means that the outcome of one coin flip would directly affect the outcome of the other. If one landed on heads, the other would instantly know to land on tails. This instantaneous connection defies our classical understanding of physics. It's as if they're communicating faster than the speed of light, which according to Einstein is impossible. This idea challenges the very foundation of relativity. This spooky action at a distance, as Einstein called it, baffled scientists for decades. They struggled to understand how such a phenomenon could occur. How could two particles be so intimately connected, even across vast distances? The answer lies in the peculiar and counterintuitive principles of quantum mechanics. The answer lies in the bizarre rules of quantum mechanics, which govern the behavior of particles at the atomic and subatomic levels. These rules are unlike anything we experience in the macroscopic world. In the quantum world, particles don't have definite properties until they're measured. They exist in a state of superposition, where all possible outcomes are possible until observation. It's like they exist in a blurry state of possibilities until we observe them. This superposition collapses into a single outcome upon measurement. When two particles become entangled, they essentially share the same fate. Their properties become linked in such a way that the state of one directly influences the state of the other. Their properties become intertwined, so measuring one instantly determines the state of the other, no matter how far apart they are. This instantaneous determination is one of the most fascinating aspects of quantum entanglement. Now you might be wondering, how do we even know quantum entanglement is real? This concept, which Einstein famously referred to as spooky action at a distance, has puzzled scientists for decades. And what does it have to do with space? The connection might not be immediately obvious, but it's incredibly profound. Well, scientists have conducted numerous experiments to prove entanglement's existence, using sophisticated equipment and rigorous methodologies. And they've found that it's not just a theoretical curiosity, it's a real phenomenon with the potential to revolutionize our world. Imagine a future where data is transmitted instantaneously, no matter the distance. One of the most groundbreaking experiments took place in 2017, when Chinese scientists used a satellite called Micius to distribute entangled photons to two ground stations over 1,200 kilometers apart. This was a monumental achievement in the field of quantum physics. They showed that these photons remained entangled even at this distance, defying the limitations of classical physics. This experiment smashed previous records and demonstrated the feasibility of long-distance quantum communication, opening up new possibilities for secure data transmission. But why go through all the trouble of sending entangled particles into space? The answer lies in the unique conditions that space offers. Well, space provides a unique environment for studying and utilizing quantum entanglement. The vacuum of space is almost entirely free of the interference that plagues Earth-based experiments. For one thing, it's a vacuum, meaning there's very little interference from air molecules or other particles that could disrupt the delicate entanglement between particles. This makes space an ideal laboratory for quantum experiments. Moreover, the vast distances involved in space exploration make traditional communication methods painfully slow. This is a significant hurdle for missions to distant planets. Imagine trying to send a message to Mars using radio waves. It would take several minutes for your message to reach its destination. This delay could be critical in time-sensitive situations, but with quantum entanglement, communication could be instantaneous, regardless of the distance. This could revolutionize not just space exploration but also how we communicate on Earth. Now let's talk about something even more mind-boggling: quantum teleportation. This concept, which sounds like it's straight out of a science fiction novel, is actually rooted in real scientific principles. I know what you're thinking. Beam me up, Scotty. The idea of instantly transporting from one place to another has fascinated us for decades. But hold on, it's not quite what you see in Star Trek. The reality of quantum teleportation is far more complex and intriguing. Quantum teleportation doesn't involve physically transporting matter from one location to another. Instead, it's about transferring the quantum state of a particle. Instead, it's about transferring quantum information, the properties of a particle, using entanglement as a resource. This phenomenon is one of the most mysterious and fascinating aspects of quantum mechanics. Imagine you have two entangled particles, A and B. These particles are connected in such a way that the state of one instantly influences the state of the other, no matter the distance between them. You want to teleport the information from particle A to particle B. This process begins with a crucial step. To do this, you first need to make a measurement on particle A. This measurement is key to the entire process. This measurement will instantly affect the state of particle B, even if it's miles away. This instantaneous change is what makes quantum teleportation so fascinating. Now here's the crucial part: you don't directly send the measurement results to particle B. Instead, you need to communicate this information through classical means. Instead, you send classical information like a text message or a radio signal that tells someone at particle B how to manipulate it based on your measurement of particle A. This step bridges the quantum and classical worlds. By following your instructions, they can transform particle B into an exact replica of particle A's original state, effectively teleporting the information. This process, while complex, is a groundbreaking achievement in the field of quantum mechanics. While we're nowhere near teleporting humans, or even single cells yet, scientists have successfully teleported the quantum states of photons and even atoms over increasingly large distances. This progress hints at a future where quantum teleportation could revolutionize communication and computing. Okay, let's address the elephant in the room. Could we ever teleport humans using quantum entanglement? The short answer is, probably not, at least not anytime soon. The human body is an incredibly complex system made up of trillions of atoms, each with its own unique quantum state. To teleport a human, we'd need to create an entangled copy of every single one of those atoms, which is far beyond our current technological capabilities. Moreover, the act of measuring a particle's quantum state inevitably destroys its original state. So even if we could somehow create an entangled copy of every atom in your body, the process would likely be fatal to the original you. But hey, let's not let the laws of physics dampen our imaginations. While teleporting humans might remain in the realm of science fiction, quantum entanglement still holds incredible potential for space exploration. Imagine a future where we could send probes to distant star systems and receive instantaneous updates on their findings. Or a network of entangled satellites that could provide us with ultra-precise navigation and communication capabilities. Speaking of networks, one of the most exciting potential applications of quantum entanglement is the development of a quantum internet. Imagine a global network that could transmit information not as classical bits, zeros and ones, but as quantum bits, or qubits. Qubits can exist in a superposition of states, meaning they can be both 0 and 1 simultaneously. This allows them to carry exponentially more information than classical bits, revolutionizing computing and communication. A quantum internet could connect quantum computers worldwide, enabling us to solve complex problems that are currently intractable for even the most powerful classical computers. It could also lead to unhackable communication networks, as any attempt to intercept entangled particles would instantly alter their state, alerting the sender and receiver to the intrusion. But the potential of a quantum internet extends far beyond Earth. Imagine a network of entangled satellites that could provide us with ultra-precise navigation and timing information, forming a sort of quantum GPS. Such a network could also facilitate interplanetary communication, allowing us to send messages to astronauts on Mars or probes in deep space with virtually no lag time. Quantum entanglement is already changing our understanding of reality, and could revolutionize how we communicate across space. While teleporting humans remains a dream, quantum teleportation of information is already happening, and could soon reshape space exploration. From unhackable communication networks to instantaneous interplanetary messaging, the possibilities are as vast as the universe itself. As we continue to unravel the mysteries of quantum entanglement, one thing is certain: the future of space exploration will be inextricably linked to this mind-boggling phenomenon. The universe may be vast, but quantum entanglement proves that even across the cosmos, everything remains mysteriously connected.